So we've talked about the importance of logging at the network and host and device level. We've also mentioned that it can be important to centrally send log information to a protected host on a different network. But how exactly does that work? Well, there are a couple of things to think about. And one is protocols that we can use to get information, to reach out over the network to acquire information about devices. And one of those protocols is SNMP, the Simple Network Management Protocol. You can use this against operating system devices, against network infrastructure devices, against apps like databases. What you can do is monitor things like bandwidth metrics. It can be a software agent that you're querying to get this type of thing, or it could be built into firmware. And at the software or firmware level, that information is stored on that device in what's called a MIB. An SNMP MIB, is a management information base. Think of it as being a little database that has statistics and some configuration settings for that host or that app or that network infrastructure device. So SNMP traps are alerts that get triggered, such as if the bandwidth going to or from this router exceeds a certain threshold or gets down to a certain threshold, I want to be notified. Because the way SNMP works is you have the SNMP agent MIBs on the devices, hosts, and apps, and you have an SNMP management station that receives those SNMP traps. You have software that's designed to do that. Now, there are other types of tools that will do this. For example, NXLog is an open source log collection tool that you can use. And a lot of these types of tools use SNMP as the underlying protocol to do what it is that they do. Now, in Linux, we can enable centralized logging using syslog forwarding. Now, the newer versions are called syslog-ng, where ng is for next generation. The idea being that we can use this kind of log forwarding to send logs to a centralized log host. Now, the way that this works is it happens over UDP port 514, at least by default. As you might expect, you can configure it to use whatever port you choose, even over TCP. But that's the type of traffic we're talking about by default. So in our graphic image, what we've got is a number of devices and workstations and servers on the network that can send their log information to a central syslog server. Now, this is a Linux thing, at least at the centralized syslog level. But that doesn't mean that all the devices that are reporting to your centralized syslog server have to be Linux-based. They don't. You can even go into a lot of consumer-grade devices like multifunction network printer devices or home Wi-Fi routers. And when you look at some of the logging settings, you'll probably get to see that you can enable syslog forwarding to a syslog host. So it doesn't all have to be Linux in terms of the devices sending log events to the log host. In the case of Windows, we can also enable centralized logging. You do this in the event viewer by creating what's called a subscription. The idea is that you configure various Windows hosts to send any logs that they generate, and you can filter it, just like you can with Linux syslog. It doesn't have to be every log entry. You can say only warnings, only critical, whatever it is, are to be sent to the central host. So in Windows, we do that by setting up a subscription. Now, if we take a look at our diagram, this is all happening over the WinRM protocol, Windows Remote Management. Now, what we have to do on all of the client devices that will send their log information elsewhere is we initially have to run something called WEC-util, W-E-C util QC. That's Windows Event Collector Utility Quick Configuration. That's going to enable WinRM traffic to come into or leave that host. Now, on the Windows Log Collector server, we can configure a subscription, and we could, for example, add the computers that we want to grab log information from. So there are a couple of configurations. You can configure the Windows server to reach out everywhere and grab log entries and pull them down. Or in the opposite direction, you could configure a subscription for the devices to push log entries to the centralized Windows logging host. However you do it, on the central Windows logging host, you can expect to go into the event viewer under the forwarded events view to see information or log entries that were sent from other hosts to this centralized host. Now, to take that a step further, in the enterprise, we have this notion of security, information, and event management. Some people pronounce it SIEM, some people pronounce it SIEM. It's kind of like saying tomato or tomato. It doesn't matter. What matters is that we know what it is and why it's relevant. The idea with a SIEM solution is that we have sensors or data sources. That could even be Windows Centralized Log Host. That could be a source to feed into our SIEM solution. Or it could be Linux syslog hosts. It could be individual devices. This is another centralized way to ingest log information. But it's not specific to an operating system like syslog is to Linux, like the event viewer is to Windows. This is designed as an enterprise-level centralized log ingestion type of service. Now I say log, it doesn't necessarily have to be logs as we specifically always think about them. It could be log files. It could also be any alerts triggered by intrusion detection or intrusion prevention systems. It could be packet captures that are being captured on any type of device. We talked about that stuff already. It could be malware alerts from endpoint malware scanners, all kinds of data sources. But the idea with a SIEM solution or SIEM solution is that you have a dashboard to make it easy where it's already analyzed everything, looking for indicators of compromise. It's very paranoid. It's looking for suspicious activity and it's trying to give you easy to read alerts on a graphical visual dashboard. That's what this does. So it also can identify trends over time. So through event correlation over time, sometimes we can see that, oh, it looks like there was a network intrusion and they had access for 2 months. If you analyze individual events independently of one another, you might never realize that. But with this kind of a solution, you would. So how does this work? Well, the process with a SIEM solution is that we have our data inputs. The data gets ingested. We then have log aggregation if we're bringing in log information. That's all dumped into one central location. Then we have an analysis of that information. And this is a common type of artificial intelligence, machine learning type of big data analytics, trying to gain security insights by looking at these vast amounts of data. That's what this does, that otherwise we would never probably see if we analyzed it manually as human beings. Finally, it generates reports and dashboard visualizations, like we said. So what might this look like? Let's go out and do a Google search. So here in my browser, I'm going to do a search for Alien Vault SIEM. Alien Vault is a company that produces tools, one of which is an open source type of tool that is serving as a centralized log collection and security incident respond type of tool. If I right-click on one of those images for screenshots and open it in a new tab, we get a sense of the type of information that we might get from a dashboard visualization. So over in the bottom right, we have a number of sensors, such as on-premises and even sensors running in the cloud. Let's not forget, we might have a hybrid environment. So here we have some AWS sensors. We've also got a lot of charts, and we've got alarms by intent that are graphed. So this way, we don't have to draw any correlations manually. We don't have to go connecting remotely to Linux or Windows machines looking at logs. This instead gives us intelligent analytic insights quickly and easily. And so that's the idea with a SIEM solution. So having centralized logging in conjunction with the SIEM solution is absolutely crucial in the enterprise for monitoring, looking for security incidents.